So today, we're going to pull back the curtain on something pretty cool. It's like a secret weapon that our favorite recommendation engines are starting to use. It's this brilliant new way they've figured out to really understand our unique tastes, creating what you could call a true digital fingerprint of what we're all about.
You totally know that feeling, right? When a streaming service just nails it with a movie suggestion, or an online store shows you something you didn't even know existed, and suddenly, you have to have it. It really does feel like magic. But behind the scenes, making that magic happen is actually a massive technical challenge.
And yeah, that really gets us to the heart of what we're talking about today, what I'm calling the recommendation puzzle. I mean, how do these systems get so good at guessing what we'll like? And maybe more importantly, what happens when they're flying blind, when they just don't have enough information to work with?
Well, it turns out the biggest villain in this whole story has a name. It's called data sparsity. It's kind of a technical term, but all it really means is that the system doesn't have enough data points on you. Not enough clicks or views or purchases. So if you're a brand new user or you only pop in once in a while, that algorithm is basically fumbling around in the dark.
Here's a great way to think about it. Imagine the algorithm is a detective, and its job is to figure you out. But with data sparsity, it's like that detective only has one or two blurry footprints to go on. I mean, how can you possibly build a full profile or guess someone's next move with such flimsy evidence? It's pretty much impossible.
Okay, so how do you solve a problem like that? This is where things get really interesting. Researchers came up with this fantastic new idea. They thought, okay, instead of just trying to predict the next thing someone will click, what if the AI could learn the very essence of a person's taste? And the way to do that? By looking at their history from a few different angles.
And this is a really fundamental shift in how we think about this stuff. See, the old way was all about simple, linear prediction. You liked item A, then item B. So you'll probably like item C. But the new way? It's so much more clever. It's all about comparison. The system actually creates two slightly different versions of your history and makes the AI figure out what they have in common. And that common thread, that's the key. That's the core of your taste.
The researchers behind this put it perfectly. The goal isn't just about prediction anymore. It's about creating a really rich understanding. They call it an encoding of your taste. And it gets there by finding the agreement between these two slightly tweaked versions or views of your own history.
So this diagram here shows the basic setup of this new model. It's called CL4SRec, which I know is a mouthful. It stands for Contrastive Learning for Sequential Recommendation. But here's the simple version. You take a user's history, you create two slightly altered or augmented versions of it. Then you feed both of those into the same AI brain, which they call an encoder. And the AI's job is to learn that, hey, these two different looking histories actually belong to the same person. And in doing that, it gets way, way better at understanding their core taste.
Okay, so the big question is, how exactly does the system create these two different views? This is where it gets super creative. It's not like it goes out and finds new data on you. Nope, it kind of bends the data it already has.
It uses these three really clever tricks that are called data augmentation. A good way to think about them is that they're just different ways of giving the AI a new perspective on the same person. It forces the AI to figure out what's really important about your taste versus what's just random noise.
All right, so the first technique is called cropping, and it's pretty much what it sounds like. It's as if the AI just zooms in on one specific chunk of your history, like, say, everything you looked at last Tuesday, and it tries to understand your entire taste based only on that little snippet. By doing this over and over, it learns to find your core preferences even when it doesn't have the full picture.
Okay, trick number 2 is masking. This one's pretty fun. The system basically takes your history and plays a game of fill in the blanks with it. It'll just randomly hide a few of the items you clicked on, and then its job is to understand your overall taste just from the context of what's left. It's forced to guess what's missing, and that exercise builds a much, much deeper understanding of your preferences. And the last one is reordering. Sometimes the exact order we click on things doesn't really matter all that much. Maybe you looked at some sneakers, then a t-shirt, then went back to the sneakers. By slightly shuffling a small part of that sequence, the model learns that the main signal here is sneakers, and the exact order doesn't matter. This makes the whole system a lot more robust and less rigid.
So, okay, we've got this really elegant theory, and we've got these clever little tricks for bending data. But the big question remains, does all this work? Does comparing and bending history actually lead to better recommendations for you and me? Well, let's take a look at the results. I mean, This is the multi-million-dollar question, isn't it? After all this complicated data science stuff, does it actually work? Do you get a better suggestion for your next movie or that next pair of headphones? That's all that matters.
And the answer is a big, resounding yes. On those sparse data sets, remember our poor detective with only a few clues, this new method, CL4SRec, boosted performance by an average of over 11%. And let me tell you, in this field, that is a massive leap forward.
Let's make this real. Check out this example from the sports dataset. The metric they're using here is hit ratio at 5. That's just a fancy way of asking, how often is the right item in the top 5 suggestions? So, that bar on the left, that was the previous best model, a thing called CL4SRec. And the bar on the right is our new model, CL4SRec. As you can see, it's not even close. The new one is finding the right stuff for people way more often.
And this wasn't just a fluke on one dataset. They tested this across a bunch of different ones: beauty products, sports equipment, even Yelp reviews. And the story was exactly the same every time. Whether you look at the top 5, top 10, or even top 20 recommendations, this new model just consistently knocked it out of the park, with improvements often getting into the double digits. It's the real deal.
So what's the big takeaway here? What does all this mean? Well, it means we're moving past just simple prediction. We're heading towards something way more profound, which is creating a much smarter digital fingerprint.
Because by learning to see the same person through all these different lenses, cropped, masked, reordered, the AI is actually boiling it all down to the absolute essence of their taste. It's not just a dumb list of clicks anymore. It's a robust, nuanced, and really accurate representation of what a person actually likes. It really is a true digital fingerprint of their interests.
So, why should you care about any of this? Well, it means you get better recommendations, especially if you're a new user on a site. It means the system understands you on a deeper level, not just based on the last thing you looked at. And it's way more forgiving if you browse a little chaotically, like most of us do. But bigger than that, this is a powerful new tool that's going to help build smarter AI across the board.
And that kind of leaves us with a really fascinating thought to chew on. We started this journey just trying to predict the next thing someone might click on, but where we ended up was creating a digital fingerprint of a person's taste. So it really makes you wonder, if AI can do that, what's the next personal frontier it's going to learn to map?